Okay, so the median of a triangle is a segment. There's three of them, but one of the medians is a segment whose endpoints are the vertex of a triangle and the midpoint of the opposite side. So let's show how to do that. What I'm going to construct right here, since I want the median to go to AB, side AB, I'm going to construct the perpendicular bisector of AB. Okay. Now, how do I do that? I put the center of my compass tool on A, and I choose a radius that's reasonably far. Now, if I don't choose a big enough radius, my two circles won't cross. Okay, and I'll show you what that means in a second. Now, I'm going to use the same radius over on B. The purpose of the same radius is so we hit the center. Two circles with the same radius, you'll hit the center of those two. All right? If we used different radii, you get perpendicular, but you wouldn't get the center. So because we're using the same radius on these two arcs, we know that we're going to get through the center. Now I'll connect those, but this is actually not the median, this is the perpendicular bisector. So realize this is the perpendicular bisector of AB, and that's not what we want. Okay? What I needed was this midpoint, I'll call it D. And then now what we can say is our actual median is when we connect C to D, because it's going from a vertex to the midpoint of the other side. So C to D is the median. And again, it's just one of the three is a median of triangle ABC. Okay, that was number 4. All right, number 5. Let's use a compass and a straight edge to construct the image A prime, B prime, C prime, which is after a dilation with a scale factor of 2 centered at B. Okay, so when we construct a dilation and they tell us the center, each point's image, say we start with C's image will travel along the same path as the center to that pre-image. C's the pre-image. We're trying to find its image, C prime. Now I know it's going to be somewhere along this line. So I'll extend this. Somewhere on this path is where C prime will land. I don't know where. Now, because I want a scale factor of 2, I'm just going to double this distance. Okay, one way to double the distance is to measure it. And again, every time we measure, we have to show this arc. I'm going to use this one. Okay, show the arc that you used the compass tool to measure. Keep that same radius. Center now at C, and then draw a similar arc. Same radius. Now that's where C prime is going to be because it's twice the distance of BC. And it's collinear is what it's called. They're on the same line. Center, pre-image, and image have to be collinear. All right, now we're going to do the same thing with A. The center is B, so A, B, and A prime have to be collinear, all along the same line. And what I have to do, again, is double the distance from A to B. So I'm going to put the center of my compass tool on B. The radius that's closest to BA is right there. There's that arc's the evidence that I used the tool to measure, and I lost it. I gotta remeasure. Okay, don't let your pen get out of there. Hopefully all of you are gonna do this in pencil on the test in case of a mistake. Okay, so that's where A prime is, and the reason is because that distance is 2 times the distance of AB. Okay, now I'll connect those if I need a larger straight edge. Okay, and describe the relationship between the lengths of A to C and A prime, C prime. First they're parallel, but that's not the lengths. Okay, parallel. But the lengths is A prime, C prime is twice the length of AC. Okay, so that's the description. That was the fifth one. All right, number 6. Then we'll pause and break it up. Okay. Use a compass and a straight edge to construct a line of reflection. Okay. Basically, the term you need right now is the line of reflection. This is the concept. The line of reflection is the perpendicular bisector of any pre-image to image segment. A little strange, okay, but I'll show you what I mean now. So I have the pre-image R and the image R prime. If I connect those with a segment, the line of reflection used to produce that would be the perpendicular bisector of R prime. So again, with perpendicular bisector, you put your center of your compass tool on one point. Okay, use a radius. It doesn't matter. I'm going to use a radius. It doesn't have to go through R, but you have to use a big enough radius where the two circles will cross. Okay, center on now R. All right, so there's the intersection of those two circles. Those points are the same distance from R prime as they are from R because they use the same radius. And that's the definition of perpendicular bisector. All the points that are the same distance from R and R prime. So this will be the line of reflection. Okay, and that's because it is the perpendicular bisector of R to R prime.